Oh, hi. Okay, look, certifications get you noticed, projects get you hired, and in the next few minutes, I'm going to show you how to build an end-to-end AWS app with Claude, the one that lands the offer. Watch this video till the end, and here's what you'll walk away with. An app where a user uploads a resume as a PDF document, and a minute later, a personal resume website live on AWS, built automatically using Amazon Gateway Lambda and Claude. The kind of project you can demo live in an interview and actually talk about. Here's a quick demo. Okay, so this is the sample application. All I need to do is obviously sign in, provide my email address, and obviously my password. So we've got authentication going there. And once I'm logged into the application, all I need to choose is the style of my resume website. So I'm going to go with dark mode today, and then choose my actual PDF document. So there it is. And then go ahead and click generate my website. A minute later, behind the scenes, Gateway Lambda Claude have done the heavy lifting and presented you this beautiful looking resume website. This is the final result, a brand new website live on CloudFront, built from one PDF, with all of the bells and whistles that you can design to your heart's content. And here's a quick architecture diagram of the project tutorial that you will be building out today. Quick intro then, I'm Rajesh. I've spent 20 years as a solutions architect and trainer, and I've helped hundreds of individuals land roles as solutions architect, DevOps, and cloud engineers. That's exactly the kind of role this project will help you get, so let's build it. So let's take a look at the business use case. Imagine you've been hired as an AI architect for a recruitment firm that wants to build a resume building web application, so that job seekers can publish their resumes as beautifully designed websites, which can be shared with potential employers and hiring managers. The workflow is as follows. A user signs up to the app, uploads their resume, selects a style, and then the application extracts the data and builds a beautiful resume website for that user. In this video, I'll show you how to build this app following a step-by-step guide. I'll explain which AWS cloud services you will need to use to build the underlying infrastructure, and how you can use Claude to understand the extracted resume data from which your website will be built. Now, before we go any further, there's one small problem. You want to build a resume web application. Someone uploads a PDF document, and a minute later, a styled deterministic website exists. The deterministic part ensures the same layout, same structure, same quality every single time, regardless of what the original document looks like. And therein lies the actual problem. Now, it's this deterministic output that's actually the hardest part. Two resumes never look the same. You got different section orders, different date formats, missing fields, inconsistent headings, two column layouts, tables, bullet styles, fonts, etc. And if we just take a look at these two resumes, for instance, you'll see exactly what I mean. So you've got two ways of describing what summary is. You've got summary and you've got professional profile, and they both mean the same thing. They both mean summary. You've got key achievements and notable achievements. That's just basically achievements, but they have been described in each of those two documents using different, slightly varying terminology. You've got work experience and previous experience, and obviously that means what experience have you had in the real world. So you can see that because your users or your customers are going to have different designs for their actual resume documents, we need a mechanism to be able to identify what each of those words, each of those phrases, sentences mean, and to be able to correctly categorize them. Because ultimately, you want an output that is predictable. Same sections, same visual hierarchy, same styling rules every single time. You may input a widely unstructured human formatted document. Some may even be handwritten, but the output needs to be a strictly structured and reliably rendered website. And so that's where I'd like to introduce you to one of the services that you'll be using in order to build out this solution as part of this tutorial. And that is Amazon Textract, which is a machine learning service that automatically extracts printed text, handwriting, layout elements like paragraphs, forms, and tables from scanned document and images. And this tool is going to help you extract the core data from those thousands of resumes that potentially your customers or your end users might be uploading to your application. Now, Textract is an excellent tool. You can upload the resume documents to it and it will extract all of the data in those documents, be they scanned images or PDF documents or whatever format it might be in. And it will be able to extract all the words, all the sentences, the layout, the bullet points, etc. But you can't simply just parse a PDF document and hope that it will have the understanding about the context of that document. So let's just take a look at Textract in a little bit more detail. So Textract obviously is this AI service for extracting text, data from scanned documents, and it can detect both type and handwritten text, which is absolutely brilliant. And obviously it goes beyond OCR by understanding the document structure. However, once you pull the text out of a PDF, what you get is a flat list of lines with no semantic meaning attached to it. Now you have to write code that must answer questions a human eye instantly understands. But code can't reliably guess. So for instance, Alice Whitfield, is this line a name or a job title? Professional summary, is this a section heading or the body text? AWS, is that a skill year or part of a company name? And what about Netcom AI training company? Where does one job end and the next one begins? That type of information, that type of understanding is not something that Textract can give you. Now, normally, to pull out information from your extraction to actually understand what the extraction is, you would create a tower of rules. So if a line reads professional summary, then there's a match. And as a result of that, we can take that extracted content and place it in a website, place it in the category of professional summary. But what happens when resume 2 arrives and it says executive summary? Same meaning, completely different words. Now the rule fails. The section vanishes and you need to go back and update your code to add yet another condition. Let's take a look at another resume. Resume 3 arrives and this one says overview. It breaks again, back to the code again. Every new format breaks something and you are back here adding another else if statement. You might be thinking, okay, I can actually clean this up. I can put those in a list, and you would, but it doesn't help because whether it's a chain of else if statements or a tidy list, something still has to keep guessing. A human has to sit there and imagine every phrase a stranger might put in their resume. You also might be thinking that you can use fuzzy matching, but look at overview. It doesn't share a single word with professional summary. It's not a typo of it. No string matching trick on earth can connect the two of them. The only thing that connects them is that you know they mean the same thing. And resume 4 is out there right now with a heading neither of us thought of yet. And so Textract actually did its job. It gave us the text, even told us this line is a heading. What it can't tell us is that the heading means summary. That's not extraction, that's understanding. And so if you haven't guessed it already, in addition to Textract actually extracting the raw text, we're going to need something that does the understanding. And that's where artificial intelligence, AI, and an LLM like Claude and its various models are going to come handy. Remember, Textract did its job. It handed us the text. The problem is everything after, understanding what that text means. And that's not a job for rules. That's a job for something that can read. So we hand over the entire extraction in its raw format to Claude on Bedrock. Claude reads it the way a person would and gives us back clean, structured JSON. Name, summary, experience, skills, education, every field, every time, no matter how the resume was written. And here's the part I love. Once we have that JSON, the guessing is over. Your code never has to wonder what a job title is again. It just drops each field into a fixed template. Claude handles the messy human side and your code handles the reliable rendering. That's what makes this work. Unpredictable input, but completely predictable, reliable, and consistent output. Now that we have a good understanding of what we're going to be needing in order to build out this application, let's go and look at the actual architecture design pattern for this app. So let's take a look at this architecture, what you are actually building in this tutorial. So it all starts off with our good friend Alice. Now Alice is going to be using this website, the AI generator website, where she's going to upload her resume in PDF format that's then going to be converted into a beautiful website. Now, the first thing that we need to do is identify who Alice is. We need authentication and authorization. And you'd rather not build a complete login solution from scratch using code, because AWS offers a service known as Amazon Cognito that handles that for you. Alice signs in and gets back a token, and now every request she makes is authenticated. Now, Alice needs to upload her PDF document, her resume, to an Amazon S3 bucket. But here's a rule you never break. You don't let the browser write directly into your S3 bucket, because that's a security hole. If the browser has write access to your S3 bucket, then so does anyone else that inspects the code. And that's how buckets get compromised. So we do this properly. The app sends a request to another AWS service called the API Gateway, which checks the user's Cognito token first. Is this a real logged in user? If not, it's rejected right there before any code runs. Once they're verified, API Gateway hands that identity to Lambda. Lambda reads the user ID straight from that verified token, not from anything that the browser claims. It then builds an S3 path with the user's ID baked in and generates a pre-signed URL key. This is a temporary signed key that's locked to that one path for that one user for just a few minutes. So the user never chooses where the file goes. The server decides from the identity they can't fake, which means that user A can never upload into user B's folder. The browser gets just enough permission to drop one file in one place and not a byte more. And that's how you let users upload directly to S3 safely. So the PDF document lands in the S3 bucket in the uploads folder. And here's where it gets really elegant, because the upload itself fires an event. Nothing stays sitting in a loop waiting. The event triggers our first Lambda function called the resume processor. Now this function, written in Python, will kick off an asynchronous textract job to pull the raw text out of the PDF document. This is what we call event-driven architecture. Each step reacts to the one before it, and that's why the whole thing cost pennies to run. Here's the clever part. Textract doesn't make anyone wait around. It does its job, and when it's finished, which could take a few seconds or maybe even a couple of minutes, depending on how complex your document is, it fires a notification into Amazon SNS and walks away. Amazon SNS is the messenger that says the text is ready, the extraction is ready. And Amazon SNS triggers another Lambda function known as the textract results processor. And this is where all of the magic actually happens. This Lambda function will fetch the extracted text from textract. And now we're at the moment where the whole video has been building towards. It hands that messy text to Amazon Bedrock, and specifically in our example, to Claude. Claude reads it like a person would and returns a clean, structured JSON with name, summary, experience, skills, all of the fields, every single one of them reliably. And now the determinism returns. The same Lambda drops this JSON into a fixed HTML template and then publishes it back to Amazon S3. Amazon CloudFront then serves it to the world, fast, secure, and global, and Alice can see her brand new website, from PDF document to a live site, fully automated. Included in this architecture are a couple of other services you would end up using. IAM and CloudWatch, for example. Now, IAM will control who's allowed to do what, and CloudWatch will watch the whole thing so that if something breaks, you know where to look. Every serious application on AWS sits on these two. And that's the shape of every application you'll ever build. Something takes an input, something processes it, and then something delivers the output. Authorization and storage take the input, Lambda, Textract, and Claude do the thinking, and CloudFront delivers it. Get that pattern into your head and you're architecting anything. Now, before we build, one idea that ties this whole thing together is as follows. Look at where AI actually sits in this pipeline. It's one step, one box. We hand Claude the messy text. It gives us back the clean JSON. And that's the only unpredictable part of the entire system. Everything after that, rendering the JSON, building the HTML, publishing it to S3 and serving it through CloudFront is just plain Python. Same JSON in, same website out every single time. So when someone tells you AI isn't reliable enough to build real apps on, that's your answer. You let AI do the understanding and your code does the building. Constrain AI to one job and everything around it stays rock solid. That's the pattern. Now let's go and build this stuff. Okay, so we're going to get started with a series of steps in order to build this application end to end. And we'll start with step 0, which is where we're going to deploy an Amazon S3 bucket that's going to host the folders to allow your users to upload their resumes to, as well as a folder where it will publish the websites for those individual users from. And in front of it, we're going to deploy a CloudFront distribution point. So pretty much this is what we're going to cover in this step. Let's get into the AWS Management Console and set this up. Okay, so here we are on my AWS Management Console. Now I'm going to be setting this up in the North Virginia region. So you want to make sure that you use the same region for all of the different steps. And ideally you want to be logged in as an IAM admin, because we will be creating what's known as an inference profile in Amazon Bedrock much later in today's session. And for that, you need to be logged in as an IAM user, not the root user. So make sure you've logged in as an IAM user with administrative privileges. Okay, so here's what we are going to be doing. We're going to go ahead and first create our Amazon S3 bucket. Okay, so I'm going to go into S3 and I'm going to create a new bucket. And this is a general purpose bucket, by the way. Okay, we're going to be using a global namespace for this, and we just need to provide it with a bucket name. So the bucket name that I'm going to use for this project is AI Resume Website Generator. Okay, something like that. So that's our bucket name. And I'm going to go all the way to the bottom, leave all of the settings as they are. This is a private bucket, so we don't need to disable block public access. We're not going to enable versioning, and I'm just going to create the bucket. There are going to be two folders primarily at the root of this bucket. There's going to be an uploads folder and a website folder. The uploads folder is going to allow users to upload their PDF documents to, and the website folder is going to be where the website is going to be published from. However, we don't need to manually create this. The code that I'll be supplying you from our GitHub repository is going to set that up for you. So we've got the bucket that's all in place, and that looks perfectly fantastic. We can leave it as it is. Let's go ahead and now create the CloudFront distribution that's going to be the front end of this bucket. So I'm going to go into CloudFront, and open that up in another tab, so it's easy to navigate between our services. I'm going to create a distribution. Okay. And you've got these different plans to select for your distribution. For the purposes of this lab, I suggest you just go with pay as you go. Okay. Unless you're going to keep the product or the application for a fair amount of time, we're just going to terminate it right after the exercise. So just pay as you go, click next, and we need to provide a distribution name. So for the distribution name, I'm going to type in AI Website Generator -CDN for Content Delivery Network. So that is our name of our distribution. You can provide a description as well if you like, and it's going to be a single website or app configuration that we're going to be using. Now, we don't have a Route 53 managed domain name for this. In the real production environment, you would obviously use a more company domain name that you would use for this purpose. But for the purposes of this lab exercise, we're just going to skip that bit because obviously this is not in production yet. Go ahead and click next, and we need to provide the origin type. Now, this is the origin of your data that's going to be served by CloudFront. And in this example, obviously it's Amazon S3. I'm then going to select the Amazon S3 bucket that we're going to be using. And that's our AI Resume Website Generator. Choose that one. And that's going to be what we're serving from. You don't need to define an origin path. The critical thing that you want to make sure is enabled is this tick box here. Allow private S3 bucket access to CloudFront. This basically means that only CloudFront can access the S3 bucket. Okay, we're not going to make the bucket publicly available or accessible unless you're coming through CloudFront. This adds a good layer of security because CloudFront gives you HTTPS connectivities, so that's encryption in transit, allows you to integrate with WAF, Web Application Firewall, for added security measures at the application layer, and a whole host of other features, including the fact that obviously it distributes your content globally using those edge locations. So leave all of the settings as they are. We definitely want that in place. What that's going to do is it's going to create a policy in S3 automatically, allowing CloudFront to access S3. Okay, so click next, and here is where you can enable the web application firewall and some additional settings for that. Again, for the purposes of this lab and to keep costs low, I'm just going to disable it for now, but in the real world, in production environments, you're definitely enabling it. Click next. That's the review and create page, and then click create distribution. Now the distribution takes approximately a couple of minutes to provision itself and be ready. So I'm just going to pause the video here, come back once it's all done. Okay, and then after a few minutes, you'll see that you will have the CloudFront distribution deployed, and it will tell you when it's the last modified date. So if we go to distribution, you will see that that is my distribution point and it's enabled. And that is pretty much step 0. Let's move on to step 1. All right, let's move on to step 1. Now in step 1, we are going to actually configure Amazon Cognito. We're going to set up something called a user pool, which is where all of your users who are using this web application are going to register themselves to be able to upload their resumes and convert them into beautiful, stunning websites. And so in this step, what we'll do is we'll set up and configure Amazon Cognito with a user pool. Alice will then be able to sign up and sign in to the account and be an authenticated user so that she's permitted to upload her PDF document to the Amazon S3 bucket, which will be converted to a website. Okay, so here we are back at my AWS Management Console. So I'm going to search for Cognito in the search box and open that up in another tab. Okay, and we're going to be creating something called a user pool, which is the directory of all of your users that are going to access the application. So from the left-hand menu, click on user pools and then click create a user pool. And specifically, the type of application you're going to be creating is what's known as a single page application. This is a single URL that updates content based on user interaction. Okay, and we need to give obviously our application a name. Okay, so we are just simply going to call this one resume app users. So a list of all our users. Now, in terms of signing in, we're going to use email address as the sign-in identifier. So when a user registers for an account, they basically register with an email address and they define a password. Okay, you've got other options there. We're not going to be using those as well. We're also going to enable self-registration so the user can go through a sign-up process automatically rather than someone in the back end having to create accounts for them. Now, required attributes for sign up. Again, you're obviously going to need email, but I'm also going to include the given name so that we have the user's name that is also provided there. And you've got a whole host of different other options that you can include if you like. Okay, now what happens when the user actually signs in? Where do they actually go? So here is where we're going to point them to the actual front end of our web application. And that's going to be a CloudFront distribution driven application. So we'll go back to our CloudFront distribution that we created. So that's the domain name there. And we're going to go ahead and paste that value in there. And specifically a /frontend.html after that. We're going to be creating a web page and HTML page later on in this project where we'll be building that front-end interface for the user to interact with, okay, the front-end UI. And that's going to be the address for it. Now, this doesn't exist at the moment, so obviously it's not going to really work, but it will work once we've got the front-end HTML page in place. So you want to go ahead and click Create User Directory next. Okay. And this is the basic setup for your user directory. Go to Overview, and there's a few additional points that I need to make, as well as a couple of changes. So first thing you need to make a note of is the user pool ID. You're going to be using this later on. And it also generates for you what's known as an app client. So there is our app client name, the one that we specified, and it's got a client ID. That client ID will be required later on as well in order to interact with Cognito. Now, if you go to login pages, and you scroll a bit further down, you need to click Edit in the Manage Login Pages configuration. So as you can see, we've pre-populated where the users go once they've signed in. What happens when they sign out? Okay, when they sign out, we might want them to go to the original page so that they can sign back in again. So we can add a sign out page, or this might be a completely different page altogether. So let's add a sign out URL, and I'm going to use the same page. So we're basically encouraging them to sign back in case they want to upload another resume doc for a website generation. Okay, scroll a little bit further down, and here you've got to make a change. So under OpenID Connect Scopes, get rid of phone, and instead select profile. Okay, so you've got email, OpenID, and profile as your OpenID Connect scopes. Next, click Save Changes. Okay, so that's our app client configured and updated successfully. Okay, we've got our sign in redirect and a sign out redirect, and also we've configured our settings for the OpenID Connect scopes. Very quickly, I want to show you what we're using. We're using what's known as the Hosted UI Classic style. This is basically a user interface with a sign up and sign in form so that the user can sign up and sign into the account. And AWS provides one predefined for you. So that takes the burden of having to build that login page yourself. You can, however, update this. You can add your own custom logo and your own custom CSS styling, so that you give the same look and feel as your website, for example. Okay, so I'm just going to cancel out of that because we're not going to bother doing that for this lab exercise. And then next, what I want you to do is scroll a little bit further down on the left-hand side, and under branding, just click on domain. Now, this is the actual domain that we're connecting to. Okay, when your front-end application goes to the website and connects with Cognito, that's where we're connecting to. Now, we can provide a custom domain name if you want to use your own company branding domain name. You will also need to consider providing a TLS certificate and using the AWS Certificate Manager to manage those certificates. Again, for the purposes of this lab, we're going to leave it at the default configuration using Cognito domain. Okay, so that's pretty much it with regards to Cognito. So if we go back to our app clients, our app client is all up and running. Okay, we've configured the login pages as well. And under overview, we've got our user pool already in place. Now, we need to test this out. We need to see whether we can create end user accounts and whether or not we're able to log in. So we'll do that in the next step. Let's move on to the next step. Okay, welcome to step 2. Now in this step, I wanted to quickly test our Cognito setup just to make sure that it works, that a user can sign up and sign in to Cognito. So let's get back into the AWS Management Console and test this out. Okay, so here we are on our AWS Management Console. I'm still in my Cognito web page, and if you click on App Clients and click on the actual app client, there is a link over here that will take you to the login page so you can see what that looks like. So I'm going to click on that. That's going to open up in a new tab, and this is what the actual web page looks like. So like I said, you can update this, you can redefine it and redesign it so that it looks similar to your particular application user interface. But obviously we need to first create an account. So I'm going to create an account. I'm going to provide an email address and my name, and then obviously put in a password and confirm that password. And then I'm going to put in my email address and then click sign up. Okay, so what happens now is that I would have received a code to the email address that I put in. So I need to log into my email account and get that code. Okay, so I got the code. I'm going to just paste that in there and click confirm account. Okay, so at this point in time, my account has actually been created. Now, I don't want you to worry about this access denied error message, okay? Do not fear. This is because when I successfully signed up and signed in, I was redirected to that CloudFront distribution point frontend.html. Okay, and as you know, that page doesn't currently exist, which is why we're getting this denied error message. And in fact, if we go to Cognito and take a look at users, you will see, in fact, my username was created. There's my email address, which is obviously blurred out, and I've got a confirmed status. Brilliant. All up and running. I can create accounts for my users. My users can sign up for an account and then use my web application. Right, that's the end of this step. Let's move on to the next step. Okay, so let's move on to step 3. Now in step 3, we're going to be creating the first Lambda function, which is going to be responsible for generating those pre-signed URLs. Now, the way how it actually works is API Gateway is going to verify the identity with Cognito, get a set of tokens, and send those across to Lambda for Lambda to be able to generate those pre-signed URL keys with. Now, we're creating the Lambda function first before the API Gateway, so this may seem a little bit out of sync, but the reason is when you create the API Gateway, you have to point it to a Lambda function to invoke. And so we need to create the Lambda function first, which is why we're doing the Lambda function first. And so what happens is once the Lambda function is up and running and you authenticate on the website and perform an upload operation, that request will invoke the Lambda function such that it will generate that pre-signed URL key and hand it to the browser. The browser then pushes the file, the PDF document, to the S3 bucket. Let's take a look at the actual Lambda function code and see how it has been written out. Okay, so the Lambda function has several moving parts to it. Firstly, we have the fact that you need to specify the bucket name that is going to be used to upload the documents to. So you will be able to download this Lambda function code from our GitHub repository in step 3. And what you need to do is you need to update it with your bucket name. And then you can use this Python code for your own Lambda function. Now, what happens down here is that the API Gateway JWT authorizer has already validated the token before this Lambda function runs. And so this sub over here is the user that is trusted, the immutable ID. Now, sub is short for subject. It's a standard field, a claim inside the JWT that Cognito issues. It's the unique permanent identifier of the authenticated user. It's a UUID. It's not an email address or a username. It's what Cognito generates when the user first signs up, and it never changes, even if they later change their email, username, and password. That immutability is exactly what you use as the S3 key. Because if you namespace your uploads by email address, for example, then if Alice ever changes her email, you will lose the link to all of her existing files. The sub stays constant for the life of the account, and so it's a safe anchor. Another thing that I want to point out about this Lambda function is the styling. So the style is picked up from the front-end website, and you will see this when we deploy the front-end web page. The style is sanitized. It reads the style from the body and then whitelist checks it against either it being dark, modern, or minimal. And so if it's not one of those styles, then it defaults to the minimum style. So we've got a dark mode, a modern style, and a minimum style to go with. This matters because the style becomes part of the S3 key. And this check stops anyone injecting arbitrary path segments, which is a security measure. Now the key is namespaced per user. So we've got uploads, the style, whether it's dark, modern, or minimal, and then the user ID. And then we have the actual resume.pdf. Now this keeps the user upload isolated under its own subject, its own sub, which downstream stages like Textract and Bedrock can then take from. Another key point about the generation of this pre-signed URL key is that it checks to make sure that the content type is a PDF document. And furthermore, the actual key will expire in 5 minutes. So as soon as it's issued, the browser needs to upload it to the S3 bucket, and it may take a few seconds. And in a worst case scenario, due to network issues, a little bit longer, but it's got a 5-minute expiration time set in motion. We also have the cross-origin resource sharing header. This allows your browser to front-end the call. It returns the uploaded URL, the key, and the user ID as JSON. So here, if you note that the cross-origin resource sharing cause is being set to a wildcard. Now, this is okay for the demo, but in production, you might want to pin this to your actual CloudFront domain, just so that you add that added layer of security as well. And then finally, it generates that pre-signed URL key and hands it to the browser. Okay, let's get into the AWS Management Console and set up this Lambda function. Okay, here we are back at my AWS Management Console. I'm still in the North Virginia region, and this is actually my development account. Now, what I'm going to do is I'm going to go ahead and quickly search for Lambda and open that up in another tab. Okay, and Lambda is where you can create your functions that can be invoked from a different source. So maybe an S3 bucket, an API gateway, whatever it might be. And essentially, this is serverless compute that you have on the AWS platform. Now, Lambda is an excellent tool to build event-driven architectures and event-driven applications, and that's pretty much why we're using it in this case. Now, on the left-hand side, you want to go down and click on Functions, and then on the right-hand side, click Create Function. We're going to be authoring our function from scratch. You will need to download the code from our GitHub repository, link of which is in the description box below. So we need to first give it a function name. So I'm going to quickly call this one something like presigned generator. Pretty much should do it. It's Python 3.14 for the runtime. And for now, we want to leave Lambda to create a normal standard execution role. So Lambda will need an IAM role in order to talk to other services. Now we will be updating this shortly, but we will let Lambda create the role first, and then we'll go and modify the role a little later on with some edit permissions. So leave everything else as it is, scroll all the way to the bottom and click Create Function. Okay, so that's the function created successfully for you. So we're going to go first and go to configuration. And here there's a couple of changes that we want to do. Now, under general configuration, you want to quickly edit this and set the timeout to 30 seconds, because it might take that little bit of extra time for it to, connect with the other services and generate that presigned URL. So let's give it 30 seconds instead of 3 seconds so that it doesn't time out. And we'll go ahead and save that. And then move on to permissions. So this is the permission. This is the IAM policy it created. So we'll open that up in another tab, and we're just going to modify that in the first instance. Okay, so here it is. And what we're going to be doing is creating an inline policy. So click on Add Permissions, click Create Inline Policy, click on the JSON tab. And from our GitHub repository, you need to download the sample JSON file that I've provided for step 3. Okay, and this is the sample JSON file. What this inline policy does is it allows Lambda to generate presigned URLs for the uploads folder of our bucket. It cannot read, write, or delete anything else in the bucket. Okay, so you want to quickly grab that, go back to the console, okay, and replace the sample policy there with your policy. And then obviously you want to make sure you update the bucket name. So our bucket name is AI Resume Website Generator. So I'm just going to copy that and place that in there, making sure to include the square brackets. We don't want them. And that's pretty much it. Scroll all the way to the bottom, click Next. And then you need to provide a policy name. So we're going to call this one Presigned Generator Inline Policy. Okay, just so we know what it is, inline-policy. Okay, scroll to the bottom and click Create Policy. So that's our policy created and updated. So it's got a standard policy when you first set this up. This policy basically allows it to send log data to CloudWatch. Okay, this is pretty standard. And we've added our inline policy for it to generate that presigned URL against the uploads folder. Okay, so next, let's go back to Lambda. Then let's go to code. Now we're going to upload our Python code. Again, you should have downloaded that from our GitHub repository. And what we'll need to do is just bring that up very quickly. Okay, so here is the Python code. Okay, and remember, we've got to update the bucket name here as well. Okay, so I'm just going to quickly copy that and go back to the console. And in code, I'm going to go to where it says code, remove the sample code and paste our code in there, and then scroll to the top and get rid of that bucket name. And we need to make sure we provide the exact bucket name as well. Okay, so paste that in there. So that's our upload bucket. All right, what it's going to do, it's going to generate a presigned URL when it is invoked by the API gateway, which we'll be doing in the next step. So that's pretty much it. Go ahead and click deploy. Okay, so that's updating the function policy generator. So that's done. Okay, so successfully updated the function presigned generator. Okay, so that pretty much concludes step 3. Let's move on to step 4. Okay, so let's move on to API Gateway. Now, API Gateway is essentially sitting in between our Cognito user pool and the Lambda function. What it does is it gets the JWT tokens from Cognito. And if a user is authenticated, if it's a valid token, it then sends an invocation to the Lambda function to generate those presigned URL based on the user details that I've logged in. Okay, so if the user is Alice, Alice will have a specific UUID that is used to generate the presigned URL so that we upload the data into Alice's folder only. That's pretty much how this workflow is going to work. If we take a look at the diagram, we'll be configuring API Gateway to sit between Cognito and the presigned URL generator. And so essentially when the user makes an upload request, API Gateway will capture the token and then subsequently invoke the Lambda function to perform that action of generating those presigned URLs. Let's jump into the AWS Management Console and set this up. Okay, so here we are back at our AWS Management Console, and what you want to do is search for API Gateway and open that up in another tab. Now we're going to be creating something called an HTTP API. There's REST API, there's WebSockets API. Those are obviously for different use cases. What you want to do is you want to click on API, right hand side, click Create API, and you want to go for the HTTP API. Click Build on that one, and then you obviously need to provide a name for your API. So here I'm going to select or type in something like Resume Presigned API. The IP address is IPv4. And then this is the important part. The API is going to trigger what when you go through it? Well, it's going to trigger the Lambda function. So we're going to add Lambda, and specifically it's the presigned generator that we created in the last step. Leave it at version 2 and click Next. Then you need to configure routes. So how do we actually trigger that Lambda function? We're going to use the post method for this. And specifically the path that we're going to be using, the resource path, is a /presigned. Okay, so that's kind of path we're going to use. And then obviously the integration target is our presigned generator. Again, click Next again. Leave the stage name to default and the auto deploy on. In real world production environments, you'll obviously be having dev, test, and prod environments. For the purposes of this lab, default is fine. Go ahead and click Next. This is the review page, and then click Create. Okay, wait for a few seconds and that should get created for you. Okay, here we are. Okay, now we've got the API in place, but obviously our API Gateway needs to now communicate with Cognito in order to get the authorization to allow the user to upload those documents to trigger that Lambda function. So from the left-hand menu, click on Authorization, click Manage Authorizers, and here you're going to create an authorizer for the JWT JSON Web Tokens type. Okay, again, we need to give it a name. So Cognito JWT token, something like that. The identity source is request header authorization. That's already filled in for you. And then the issuer URL is going to be the Cognito user pool ID. Okay, but you need to provide the full URL. So that's the https://cognito-idp.us.-east-1.amazonaws.com. So obviously if you're in the US region, then that applies. And then you need to provide your user pool ID. Okay, so go back to Cognito. Under Overview, grab your user pool ID and just replace that placeholder value there. Okay, so that's done, right? Next, you need to provide who the audience is. That is where you need to enter the client ID. Okay, so click Add Audience, go back to Cognito again, click on App Clients, click into your app client and grab the client ID. Okay, so that we know exactly what the audience is. So go ahead and add that. And then once you've added that, go ahead and click Create. Okay, so that's your Cognito JWT authorizer, and that's in place, connecting to the correct user pool ID and having the client ID. Right, next, what we need to do is we need to add the authorizer to the route that we're going to be using. So here, you want to basically attach the authorizer to the routes tab. So you want to go back to routes, okay, click on Post, and you want to attach that authorizer you just created to the route. So attach authorizer from the drop-down list, click the Cognito JWT authorizer, make sure you click the attach button, and then you want to go down and click on Save. Okay, so that's now attached to that post method, that route. Okay, there's a couple of additional configurations that we need to do with our API gateway. Firstly, we need to enable CORS, cross-origin resource sharing, so that we can allow resources from different domains to be loaded by the browser. Specifically, we're going to be loading resources, or we're going to be getting connectivity from our CloudFront distribution domain. So that's why we need to enable CORS for that. So click on CORS and then click Configure, and in the access control allow origin, you want to put in your CloudFront domain there. So if we go back to CloudFront and just get the domain name, go back to API gateway and paste that value in there. And then you want to make sure you put HTTPS before that and then click add. So that's your access control allow origin. So that's the origin from where we're accepting connections. Then you'd also need to provide access control allow headers. Now for this one, you simply need to provide authorization. So it's the authorization header. Okay. And then you also need to provide content type. Okay. So just content -type and click add. In terms of the access control allow methods, we're going to be allowing the post method and the options method. And then pretty much everything else has remained at their default values, and go ahead and click save. Okay, so this is what your screen should look like. The actual domain from where we're allowing cross-origin access, the headers, and the methods. And then we are pretty much good to go. Right, next, scroll a little bit further down. And if you go to stages and click on default, this is the invoke URL. This is what we are going to use to call API gateway from our web application. Now we'll be needing this invoke URL a little later on, so just make a note of that. Now that's pretty much it. That's your API gateway all set up and ready to go. Let's move on to the next step. Okay, so step 5 is where we're going to deploy an Amazon notification service. We're going to set up what's called an Amazon SNS topic. Now this is going to be the bridge between the Lambda function that instructs Textract to extract the text from the PDF document, and then subsequently notifies a downstream Lambda function to process that extraction. Okay, so let me bring up the original diagram very quickly to recap on this. Okay, so here's our original diagram. Now, Amazon SNS sits in between Textract and a downstream Lambda function. Okay, essentially, Textract is going to be instructed to extract the raw data from the document that gets uploaded in the Amazon S3 bucket via this Lambda function. Once the extraction is complete, because it is an async operation, we basically give Textract to do the extraction job, we wait for it to complete, and then Textract sends a notification to this downstream Lambda function to proceed with the next step in the workflow, which is to extract that text and send it across to Claude. And so we need to set up that SNS topic next, which is what we'll be doing. Let's get into the AWS Management Console. Okay, so here we are back at our AWS Management Console. I'm going to search for SNS and open that up in another tab. And in SNS, we're going to create a topic for this workflow. Okay, so on the left-hand side, you just need to click on topics. On the right-hand side, click on create topic. We're going to be creating a standard topic as opposed to a first in, first out topic. And for the name of the topic, I'm going to use something simple like Textract complete. Okay, so that's the actual name of the SNS topic. And you can use that as a display name as well. Scroll all the way to the bottom and click create topic. Okay, so that's our Textract topic up and ready. And that's pretty much it. Quick and simple. Let's move on to the next step. Okay, so in step 6, we're going to actually be creating an IAM role so that Textract can have permissions to actually send a notification, publish a message to Amazon SNS to say that it has completed the extraction of the data. Now, when we create the Lambda function that's going to basically invoke Textract, we're going to also get the Lambda function to supply Textract with the role that it needs to use to send on that message to SNS. So you can see how this is all chained up together. And so essentially what we're going to do in this particular step is we're going to go ahead and go into IAM and create a role for Textract. Let's do that next. Okay, here we are back at our AWS Management Console. I want you to search for IAM and open that up in another tab. Now we're going to be creating that IAM role. So click on roles, and on the right hand side, click create a role. It's an AWS service role, and specifically you're going to create it for Textract. So select Textract from the drop down list and click next. Now we're going to go ahead and click next. There is in AWS management policy there that I want to talk about in a second, but just click next for now. And let's give our role a name. I'm going to call this one Textract SNS role. Okay, so there it is. Just make sure there are no spaces and scroll all the way to the bottom and click create a role. So that's our role created. We'll quickly search for it again. There it is, Textract SNS role. Now, we need to create an inline policy that allows Textract to be able to send that notification of the fact that it's completed the extraction to SNS. Now, there is actually a predefined AWS managed policy already built in. And this policy is allowing you to send messages to SNS. So you see it's got the action SNS publish for any resource that begins with the phrase Amazon Textract. So if we had named our SNS topic Amazon Textract something, then that would be fine. We could just use this existing policy. However, note that the policy is broad. So that's any SNS topic beginning with the phrase Amazon Textract. So if we want to follow the principle of least privilege, we really want to actually add our own inline policy instead. And if anything, remove this policy altogether. Okay, so let's go ahead and create an inline policy. And again, you will find a copy of this policy available to you in the GitHub repository, the link of which is in the description box below. So I'm going to click add permission, create an inline policy, click on JSON, put policy there that we're going to replace. Now, let me just quickly show you the actual policy. So again, it's in our GitHub repository. It's literally 10 lines. You want to copy all of that to your clipboard and then go back to the IAM role that we were configuring and replace that there. And then what you want to do is you want to paste in your SNS topic AR in here. So if we go back to the Textract SNS topic, okay, Textract complete, we can get the AR in from there. And you want to go in and replace that value there. So make sure you get rid of the square brackets as well, but keep it the speech quotation marks there. Okay, so that is our policy. And then what we're going to do is go ahead and click next. And we will need to give it a policy name. So I'm just going to call this one Textract SNS policy. Okay, so we know what it is. And then we can create the policy. Okay, so that is our Textract SNS policy. So this policy is going to allow Textract to publish to only this specific SNS topic, which is what we really want to do. And so once we've got this in place, we can go ahead and get rid of that more broader policy there. Okay, so what we can do here is literally just click that and click remove and get rid of that. Okay, so now we've just got this policy. Now there's one more set of permissions that obviously is needed here, and that is for Textract to be able to actually pull the data from S3. So it needs to be able to read S3. So we need to add the S3 read permissions. So click add attach policy, search for S3, look for S3 read-only access. Okay, now I'm just selecting that broad read-only access, but you can even granularly configure that so that it only is looking for that bucket. And so here you can see the trade-off, right? You can actually build an inline policy for that as well if you wanted to, just to make it even more secure. So that is how we're going to do it. We got the S3 read-only access so that we can go and access the PDF document and extract the text from it. And then we can send a notification to SNS once the job is complete. That is our IAM role all set up, ready to go. Let's move on to the next step. Okay, welcome to step 7. Now in step 7, pretty much what we're going to be doing is we're going to be building out that Lambda function. So remember, we've just done the SNS topic. We've done the IAM rule for the SNS topic. And when someone uploads a document to the S3 bucket with their resume, it needs to trigger a Lambda function. That Lambda function is going to call Textract to extract the content of that document and then send on that confirmation that the extraction is complete to SNS. And so Lambda is going to start the Textract async job and provide the SNS topic details to Textract so that Textract knows where to send the notification to. And so we're going to go ahead and now build out that Lambda function. This is step 7. Remember, you need to download the code from our GitHub repository in the step 7 folder, the link of which is in the description box below. Let me bring up that code and then we'll go ahead into the AWS Management Console and set this up. Okay, so here is that Lambda code, right? So essentially what we're doing is we are going to be using the Textract Boto client for this. And there's a couple of variables that we need to provide Lambda because Lambda is going to forward this on to Textract. One is the SNS topic that we actually created, so the ARN for that SNS topic, and also the role that we just created in the last step, the ARN for that Textract IAM role that we created as well. So we'll get into the AWS Management Console and grab those in a second. The next part of the Lambda function, basically you need to remember that Amazon S3 is going to trigger this Lambda function. That event is going to be passed to Lambda, and contained in that event are going to be things like the bucket name. So this is just a extraction of that bucket name, as well as the file that was uploaded. In this case, it will be resume.pdf or whatever it is, PDF document that contains the resume details. We're also using URL lib parse uncode plus, which converts URL encoded characters of the key of the file name back to the original form so that Textract knows exactly where that file is and it's able to capture and get that file. Another thing that we're doing is we are going to make sure that we run a little bit of a validation here. So if the file does not end with a .pdf extension, then we're just going to skip it. Okay, we're not going to work with that particular file. So there's a bit of validation going on here. And then finally, we're starting the async Textract job, okay, using the bucket name and the key that is supplied from S3 when the object got uploaded, and providing the notification channel for Textract to send out that job completion information to the specific topic and the necessary role required to push to that topic. And finally, at the end, there will be a job ID. So Textract immediately returns this unique job ID that can later be used to retrieve the extraction results, which will be done by our downstream Lambda function. Right, let's get into the AWS Management Console. The first thing we need to do is update these two variables, and then we can proceed to set up our Lambda function. Okay, here we are back at our AWS Management Console. I'm in the IAM roles Textract SNS role. And what I want to do is copy that ARN, go back to my Visual Studio Code, and literally paste that value in there, making sure to get rid of the square brackets, but keeping it within the quotation marks. Go back to our Management Console, and here I'm going to go into Textract complete SNS topic, grab the ARN there as well, copy that to my clipboard, go back to my Visual Studio Code, and paste it in there. Okay, so pretty much this is what you have. Right, that's done. Let's copy all of that to the clipboard and go back to the AWS Management Console and set up the Lambda function. Okay, so here we are back at our AWS Management Console. Go into Lambda. We already have our presigned generator in place, and we're going to create a new Lambda function. Okay, and you want to make sure that this one, we're going to call it the resume processor. Okay, so I'm literally just going to put that in there, resume processor. Make sure you've got no spaces in between. And the runtime is going to be Python 3.14. Okay, so next, permissions. Now, by default, Lambda will create an execution role with permissions to upload to CloudWatch logs. That role it creates, we're going to update that. It needs some additional permissions as well, because even Lambda needs to talk to Textract and to SNS, okay, as well as the ability to read the file from S3. So we'll go ahead and create the function. Okay, so that's our function getting created. Then I want you to go into configuration. A couple of things we need to do here is we need to update this to say 30 seconds as well. So we give it sufficient time and it doesn't time out. Okay, so 30 seconds. And then let's save that. Next, what we need to do is update the permission. Okay, so go to permissions, and there is the role that it created for us. We're just going to go into that role and update that role with some additional permissions. So currently it only has permissions to write to CloudWatch, and we'll add the following policies. So the first one we want to do is add the Textract full access policy. And again, this is a broad policy. right? All we're doing is we're actually starting an async job with TextRack, but you can configure that if you want to and make it more granular. The next one that we need is S3. We need to obviously be able to read the file in S3 and hand that over to TextRack to tell TextRack, what the file is. So for S3, you just want to select the S3 read-only access policy. Scroll a bit further down, click Add Permissions, and you should now have obviously in place 3 policies. One is the basic Lambda execution role that allows it to write to CloudWatch, the TextRack full access, and the S3 read-only access. Okay, so the next thing that we're going to do is we're going to go back to our Lambda function. Okay, go to code, and if you get this message, just say accept. But essentially what you want to do is you want to overwrite the sample code that's there with your Lambda function code that you have updated with those variables. Okay, so literally going to get rid of all of that and paste in our code. Okay, so this, if you look at it, it's got our SNS topic ARN, TextRack role ARN, and it's going to do all of the necessary bits and pieces to get TextRack to do the extraction and to supply the job ID. So that pretty much looks all good to go. We can now go ahead and basically deploy that code. Okay, so click deploy. Okay, so that successfully updated the function resume processor, and that is looking good to go. Right, now remember, this function needs to be triggered by Amazon S3, specifically when someone uploads an object to S3. And so S3 is going to be the trigger for this Lambda function. We'll do that in step 8. Okay, this is step 8. Now we've already created the Lambda function, which is the resume processor, but it needs to be triggered by an action. It's an event-driven solution at the end of the day. So when someone uploads that resume to the S3 bucket, that generates an event. Specifically, it's an object create event when that put object operation happens. And that's going to be the trigger that's going to get that Lambda function invoked, which is then going to instruct TextRack to do the extraction. So essentially what we're doing here is we need to make sure that for this Lambda function to run, we add that S3 trigger. Also, bear in mind that we need to upload our resume files and objects to a specific folder, and that's going to be the uploads folder in the S3 bucket. Now, it's going to create the uploads folder for you once it completes the entire process. But this is a critical point to bear in mind. Okay, you don't want to upload it to the root of the S3 bucket or in a different folder, because then things are going to get all messed up. So we need to upload it to the uploads folder, which we will specify when we create that S3 trigger. So let's jump into the AWS Management Console. Let me show you how to set up this portion of the Lambda function, specifically the S3 trigger itself. Okay, here we are back at our Lambda function, and the next thing that we need to do is click Add Trigger. And the source of that trigger is, you guessed it, Amazon S3. And specifically, the bucket that we're going to be triggered from is the AI resume website generator, or whatever name you called your bucket. Okay, the event type is all object create events. And we need a prefix, so specifically uploads /. Make sure you put the / at the end of it, because that's the prefix of the key of the object name that will be uploaded. Okay, now you want to click I acknowledge that using the same bucket for both input and output is not recommended. In real world production environments, you probably have a completely separate bucket to generate the websites, to host the websites that have been generated, as opposed to having them all in the same bucket. But for the purposes of this lab, we've kept it on the same bucket. The reason is, remember, when you upload something to this bucket, it will trigger the Lambda function. Now, if it happens to be in the same folder as where the resume websites that are later generated are being uploaded to, well, that's going to trigger this Lambda function again, and we're going to end up in an endless loop, and we don't want that. But to avoid that, we're uploading our objects, our PDF documents, to the uploads folder, and the actual websites will be deployed to a different folder, the website folder. So we won't have that problem. So that's how we overcome and work around that issue. But in the real world, you probably want to have 2 separate buckets. Okay, so let's go ahead and click Add. And the trigger AI resume website generator was successfully added, and you can see that the icon is there as well. And so we're ready to go. Okay, let's move on to the next step. Okay, welcome to step 9. Now, step 9 is where we configure Amazon Bedrock, and Amazon Bedrock adds intelligence to this entire application stack. Essentially, what's happening is Textract extracts the raw data from the PDF documents, sends a notification to SNS, which triggers a downstream Lambda function. This Lambda function fetches the extracted results from Textract and then sends that across to Amazon Bedrock, and we'll be using Claude as our LLM in this particular case, with an instructional prompt to generate a structured output from that raw extracted data. And essentially that prompt is going to get Claude to evaluate the Textract data and generate a JSON set of key value pairs covering name, email, skills, experience, education, and certifications, etc. And essentially what we're doing here is we're analyzing that raw text and we're converting that raw text into something that Lambda can simply plug into an HTML template. Because Textract doesn't quite understand the semantic meanings of the variations of words and phrases that might be used from one user's resume to another user's resume, we need Bedrock to help us with that intelligence element here. And specifically, we'll be using Claude to help us out in semantically understanding that extracted data and generating that JSON output. Right, let's get into the AWS Management Console, get into Amazon Bedrock, and we will be configuring something called an inference profile, which will be used by the application. Okay, so here we are back at our AWS Management Console. So I'm going to do a quick search for Amazon Bedrock and open that in another tab. Now, Amazon Bedrock gives you access to all of the large language models to help you build your AI-driven applications, along with a wide range of other tools and services to build end-to-end AI-driven solutions. Now, we're going to be setting up something called an inference profile, and specifically, we're going to configure it to use Claude Sonnet 4.6. That's going to act as our LLM model in order to analyze the raw data and then convert it into JSON text with a specific output. Okay, so here on the left-hand side, you need to go down to Inference Profiles and click on Application and create an inference profile. Okay, and we're going to call this inference profile a name. We're going to call it Resume JSON Generator, something like that. Or to do it, you can give it a description, and the model we're going to be using is from Anthropic, and specifically Claude Sonnet 4.6. Okay, version 1, US Anthropic Claude Sonnet 4.6. Click Apply. So that's a model we're going to be using. Need to give it a tag. So here we'll just call it name, and we'll basically call it Resume JSON Generator as well. Okay, so that is pretty much it. Click Create Application Inference Profile, and that has generated the profile for you. So pretty much if we go into this, we're going to be making a call to Bedrock and specifically to Claude Sonnet 4.6 to help us convert that raw extracted text into a JSON output, which is obviously defined in the Lambda function we'll be creating in the next step. So this part of it is done. Let's move on to the next step. Okay, welcome to step 10. Now in step 10, we're going to create and configure the Textract results processor Lambda function. This is where all the real work happens. So the Lambda function is going to fetch the extracted data from Textract, send it to Claude with an instruction prompt to convert that raw data into a JSON output. Now that JSON output needs to follow a certain pattern with specific headings like education, experience, skills, etc. And it's then going to inject that JSON into a template, an HTML template, which will then get pushed up to Amazon S3 and be rendered as a resume HTML website that will then be delivered via CloudFront. So you can see this Lambda function is the main workhorse of this application. Okay, so next, let's go ahead and configure that Lambda function. But before we do, let's actually take a look at the Lambda function code and see some of the more important sections in the code itself. Okay, so here we are with our actual Lambda function. This code is available to you in our GitHub repository. You will need to download this from the link in the description box below. So let's just go through over this Lambda function very quickly. So the first part obviously is the necessary clients to talk to Textract, Bedrock, and S3. And you will need to provide your bucket name, as well as the model inference profile from Bedrock that we created in the last step. Okay, so those are the two key variables that you need to provide this particular Lambda function. In addition to that, if you take a look at the individual blocks, the first block is fairly simple. This receives the SNS notification from TextRact. It extracts the job ID to identify which extraction results to retrieve in order to carry out the exercise of sending it to Claude and getting the JSON output from it. So this is where we basically are looking for the actual TextRact job ID. And it also checks whether the TextRact job succeeded or failed. If it fails, it just exits. Okay. Next, what it's going to do is it's going to actually take a look at the S3 object itself. Okay, so this block retrieves the S3 object key, the actual file part from TextRact notification. It then uses the split command to basically break that into individual folder names, making it easy to extract the website style. Okay, so specifically the list that comes out from that split, because the split is uploads style user ID and then the actual document, the second folder, if you will, is where we will identify the style that was selected by the user. So that could be dark, modern, or minimal. In addition to that, there's actually a validation here so that if it's none of those, if it's not dark, modern, or minimal, it chooses minimal as the default style to use. Okay, so we've got a bit of validation going on there. And then obviously it extracts the user ID as well so that it knows where to upload the final HTML to. Okay, so next we've got the TextRact text section. So what happens is TextRact breaks the document into different types of blocks: words, lines, tables, forms, etc. And we're specifically looking for a line block representing one line of text exactly as it appears in the document. So for instance, your resume will have the name of the user, John Doe, at the top, followed by software engineer, followed by email address. TextRact extracts the 3 line blocks as individual lines. Okay, you're essentially trying to ensure that Lambda ignores everything else, like individual word blocks, and keeps only the line blocks because they're much easier to construct into readable text. Also, because the resume could have multiple pages, we want to go through each page and extract line by line until we get to a stage where there's no more lines left in that extraction. Okay, so that's pretty much what this block does. The next block, the Bedrock JSON block, now this is really a important block. This creates a prompt, okay, where Bedrock will extract structured JSON information from the resume and return it as a JSON format. So this is the format we wanted in. We want Bedrock to return the extracted data in this format: name, summary, LinkedIn URL, key achievements, experience, which has some sub names, title, company, start date, end date, etc., education, and skills. We only want the data in these specific headings. Okay, so Bedrock and Claude in this case needs to understand the document carefully and be able to extract the data specific for these headings. So that's what we're looking for. And then once it's got that data, we want to make sure that we follow certain rules as part of that prompt. So use all the information from the resume, extract key achievements as a separate array, extract the LinkedIn profile URL if present, otherwise leave that as an empty string. Do not merge achievements into summary, do not omit anything, and obviously do not invent anything, right? We don't want any hallucinations going on in the background there. Now, we're going to be using obviously Bedrock, and we're using a specific model ID, and that is defined above. So if I scroll right to the top again, you will see I've specified the model ID, which is the inference profile, in this case, Claude Sonnet 4.6. Okay, so that's what we're going to be using to do the JSON conversion. And then obviously, once we've got that JSON output, we're going to convert it into a Python dictionary, so data can be easily accessed and used in the remaining steps. This section, the format data section, takes the structured JSON output from Bedrock and converts it into HTML by inserting the resume data into the correct sections of the website template, such as achievements, work experience, responsibilities, etc. And this creates the dynamic content that's displayed on the finished website. And then obviously we've got the styling. So here we are choosing different styles to display and define that website in based on whether it was dark, modern, or minimal styles. And then we go on to produce the final HTML output that will then be used to build out that website for the user. Okay, so that's pretty much all of the Lambda function code itself. Let's move on to the AWS Management Console and actually set this up. Okay, so here we are back at our AWS Management Console, and we were configuring Bedrock inference profile, the application inference profile, in the last step. In this step, we're going to go to Lambda and create our third Lambda function. So click create a function, and the name of this function is going to be TextRact Result Processor. Okay, it's going to be using the Python 3.14 runtime, and we're going to scroll a bit further down, and it's going to create a permission, a Lambda permission execution role, which we're going to update shortly. Okay, and let's just go ahead and create the function first very quickly. Okay, so that's our function created. Now what we need to do is make a couple of adjustments. So the first thing we're going to do is go into configuration, and I'm going to change the timeout period to 5 minutes, just in case it takes a bit of time to render that HTML document. Okay, and go ahead and click save. The next thing is we're going to go down to permissions, and we're going to open up that permission that it created for us, that policy, that role it created for us. And in there is the standard Lambda execution role, which allows it to send log information to CloudWatch, which we will need. Okay, so that's fine, but we need some additional permissions. Specifically, we need to add a policy that allows it to access TextRact. Okay, so we're going to give it full access to TextRact. And also it needs to access Bedrock, right? Because it needs to send the data to Bedrock so that Claude can convert it to the JSON output. So Bedrock full access. And then finally, let's also put in S3 full access as well. Now, we're doing S3 full access, but again, we should really be configuring this specifically to that bucket, right? To that AI resume website generator bucket. And you can do that in production environment. For the purposes of this lab, I'm just doing S3 full access as well. Okay, let's go ahead and click add permissions. And so then we've got our permissions in place. Fantastic. Right, let's go back to the TextRact Result Processor Lambda function. And now we can upload the code. So click on code. So let's get rid of the sample hello from Lambda code. And let's go ahead and paste in that Lambda function. So let's go to the Lambda function first. We need to remember update the Lambda function with a couple of values. So specifically, we need the bucket name. So I'm going to quickly grab the bucket name. So that was the AI resume website generator. Just grab that name. Okay. And let's plug that value in there. Make sure to remove the square brackets as well, keeping it within the quotation marks. And then we also need the inference profile. So that's our Bedrock resume generator using Claude Sonnet, and we need the ARN for that. Okay, and we go back to the code, and here we are. We're going to update the Bedrock inference profile. And that's pretty much done. Okay, so copy all of that to the clipboard, back to the TextRact Lambda function, and paste it in there. Okay, there's 715 lines of code in there. Oh, the end of the code just basically tells you in your CloudWatch when it's successfully uploaded the file to S3. Okay, so there we are. So go ahead and click deploy. Okay, and that's now deploying your Lambda function. And it successfully updated the function TextRact Result Processor. Fantastic. Okay, so we got our third and final Lambda function in place. Now, the last thing we need to do as part of configuring this Lambda function is actually add a trigger. We need something to invoke this Lambda function. And if you remember the diagram from the slide, that's going to be SNS. So TextRact completes the extraction, sends a notification to SNS, which then sends it to the subscriber, which is going to be this particular Lambda function. That information that the extract has completed its job needs to be pushed out to this Lambda function, so that Lambda function can now go and fetch that extracted data and send it across to Claude. So simply we need to add a trigger, and then obviously we're going to be selecting SNS as our source, and specifically the topic called extract complete, which we created earlier. Go ahead and click add, and that's going to add your notification. Fantastic. So if we went back to SNS very quickly and I go into extract, and you will see that we have now a subscriber for this notification, which is our extract result processor. Fantastic. Now, the next thing we need to do is actually build that front-end website. So you remember we've got our CloudFront distribution point, okay, which is that one over there. So that's our CloudFront distribution, right, for our AI website generator. But we have the distribution / frontend.html. Frontend.html is where the user will sign up, sign in, and then be able to upload their resume. So we need to build that front-end web page, and we'll be doing that in the next step. Okay, welcome to step 11. Now in step 11, we're going to configure the front-end HTML web page. Now this is provided to you in step 11 of our GitHub repository. Again, you need to make sure you download that, and you will need to edit it with some configuration information. Essentially, this is the page that the user is going to see when they first connect to our website. The configuration will allow the web page to integrate with Amazon Cognito and present the hosted UI where the user can sign up for an account, and if they have an account, sign in to the application. That is going to generate a token which will allow the user to upload their resume document to S3. It's essentially going to call API Gateway in the background, and that will trigger a Lambda function to generate the presigned URL, which allows us to put the file directly into the S3 bucket. And then, as you know, once the file gets uploaded to S3, that triggers a series of events that happen, which involve calling extract to extract the data from the actual resume, and then subsequently passing that information to a downstream Lambda function, which pulls that raw data and sends it to Claude to generate the JSON, and then use that JSON text to generate the actual website. Meanwhile, the user browser is going to poll CloudFront until the generated site exists, and then redirect the user to their website where they will see their actual output, which is the live resume website that they can then use to share that link to hiring managers, recruiters, and so on. So that's pretty much the workflow over there. And so really, this is the last leg of our configuration. So once that workflow goes through, extract results processor Lambda function generates that HTML document, uploads it to the S3 bucket in the website folder, and then that is presented via the CloudFront distribution point. So let's go ahead and take a look at this actual front-end code, because you're going to need to make some updates to it. Okay, so here we are on my Visual Studio Code. I've just opened up the front-end code. This is in step 11 of the actual GitHub repository. So obviously you need to have downloaded this. Now, when you open up in your IDE, such as Visual Studio Code, I want you to go down all the way to lines 66 to 72. That's where we're going to make the updates. You're going to need to provide the Cognito domain, the client ID for the user pool, the redirect URL, which is the CloudFront URL, followed by a / frontend.html, the API endpoint for the API that we built, and the CloudFront URL for the base URL. Okay, so these are the values you need to update. So I'm going to go back to the AWS Management Console and copy these values. Okay, so if I go into Cognito, I need the actual domain name. So here we are. So this is the Cognito domain. So that's what I need. I'm going to go back to the IDE and paste that value in there. So fairly simple, keep it within the quotation marks. Then we need the client ID. So let's go and get the client ID. So that's under Cognito, application, app clients, resume app users, and there's our client ID. Copy that to the clipboard, go to the IDE and update the placeholder value. Then we need the CloudFront URL. So let's go back to our management console, into CloudFront, grab the CloudFront distribution domain, back to the IDE and paste that value in there. Okay, and you want to put HTTPS before this, okay? So that's the full URL. frontend.html. Okay, and this is the frontend.html page that we're actually building. Okay, let's go to the API gateway. Okay, so we've got the API gateway, and under deploy stages, there's your invoke URL. So you want to copy that, go back to the IDE, and the API endpoint is the invoke URL / presign. You need to make sure you put that in place, otherwise it's just not going to work. Next, we need to provide the base website URL. Again, that's just the CloudFront distribution. So just to remind you where I got that from, CloudFront distribution, domain name, same thing. Back to the IDE, and then place that value in there. Okay. Right, and make sure you put the https://. Right, so these are the values that you're going to update. The rest of the front end page literally lists out the sign in and sign out pages, okay, and also gives you the option to select the actual styling of your website, so minimal, modern, or dark. So this becomes part of that path that gets created in the S3 bucket, and also allows the Python script running in the Lambda function to design your HTML page. Okay, also there's a little validation here to make sure that we're using PDF documents only. And then there is a button to click the upload so that you can upload your resume. Okay, so a fairly simple front-end web page, nothing too complex. There's a few other bits and pieces. The post method for actually sending the document and uploading it. And pretty much that's really it. There isn't much happening here other than a basic website page for you to sign up, sign in, connect to the Cognito UI, and then subsequently have the option to select the styling and then upload your document. Okay, so fairly simple. Right, let's save this. I'm going to save it in a different directory. File, save as. Okay, so don't want to overwrite the template. Just going to say final, okay, create a directory, and I'm just putting it in here, frontend.html. And then obviously the next thing that we need to do is we need to upload this HTML page to our S3 bucket. So let's do that next. Going to go to the S3 bucket. So there it is, the actual website generator bucket. And we're going to upload the front end here. Now in my screen, you're looking at an uploads folder. Just ignore that. That wouldn't be there in your setup. Okay, this is because I was doing some testing earlier, so just ignore that for now. But essentially, I'm going to upload, and I'm going to literally drag and drop the frontend.html web page in the root of the bucket. Okay, so let me just bring up the actual file. Okay, so there is the final one that I made with the changes. Drag and drop it in there and upload that. Okay, so that's done. That's uploaded. And there it is there. Now, there's one final thing we need to do. You need to understand that we are accepting an incoming request from a CloudFront distribution domain name. And so we need to enable CORS for that, cross-origin resource sharing, so that we don't get blocked out. Okay, so there is a configuration template that I've provided you for this as well in the same step folder. And essentially, this is because we're going to be putting a put request. So putting the file directly into S3 using that presigned URL. Now, without CORS, the browser will block the request before it reaches S3. Okay, so in the same step folder, so you'll be looking at the step folder where you have the front end, there is a CORS config JSON. Let me open that up in Visual Studio Code. And literally all you need to do here is provide the CloudFront distribution domain. Okay, so let's just go back to the console up here, grab the distribution domain name, back to my IDE, and literally I need to, within the speech marks, place in that value. And of course, like I said, this is a URL, so this needs to be https://, and that pretty much is it. Copy all of that, go back to the S3 bucket, let's go to permissions. Scroll a bit further down. Here you can see that there is the bucket policy that only CloudFront is allowed to actually connect to this bucket. Okay, so if you scroll a bit further down, there it is. Cross-origin resource sharing. Let's edit that. And in here, we're going to paste in those values. Okay, so we're going to allow put from our cloud distribution domain. Okay, and then scroll a bit further down and click Save Changes. All right. So now our S3 bucket is ready. Our CloudFront distribution is ready. We have our 3 Lambda functions all set in motion. We've got our API gateway. We've got our textract SNS topic. We've got our IAM roles required for all of this to work. We've already configured Bedrock with an inference profile. We pretty much have done everything that we need to do as per that diagram, right? So you know what we're going to do next. We're going to actually do a demo. Let's see if this thing actually works. I'm super excited. Let's move on to the next step. All right, folks, this is step 12. This is where we actually do the demo. And this is where I'm super excited. So all of that hard work you've done, all of those chain together of the various AWS services, the S3 bucket, the CloudFront distribution, the Cognito, the API gateway, the Lambda functions, the textract configuration, and Bedrock ultimately allow you to build a real solution to a real problem. And from a user perspective, they should be able to sign up. Once they've signed up, they should be able to sign in, authenticate with Cognito, upload their resume, select a style of their resume website, and in the background, AI, particularly textract, is going to extract that raw data. We're going to use that raw data and hand it over to Bedrock, specifically Claude. Claude's going to understand the context and build out our JSON formatted output. And then we're going to use Python to basically build out that website for us based on the predefined template, the predefined style that the user selected. Awesome. Pretty much from start to finish, the user should see their end website in a matter of seconds. All right, let's get into the AWS Management Console and test this out. Okay, here we are back at our AWS Management Console. So I'm going to quickly grab the distribution domain name, open up another tab, paste that in there, and go into the front-end web page. So this is what the front-end web page looks like. Now, it's a simple front-end web page. Obviously, it doesn't have any logos or anything, but you can update that HTML page easily and make it more aligned with your corporate organization if you're going to be building this as an actual product, right? But essentially, you're going to click on the sign up or sign in page. Now, this is going to take you to Cognito. Okay, this is the Cognito UI that I spoke about right at the beginning of this project. And obviously this too can be customized to align with your corporate image, your corporate design styles, color schemes, and all that wonderful stuff. Now I'm going to sign in with the account that I'd created right at the beginning as an example. Okay, so I'm just literally blurring out the email address. And if I click next, okay, then I need to put in my password. And if I click continue, that's going to redirect me to the front end page. And you can see it there in the actual address bar. Now I've signed in. Cognito has given me authentication and allowed me to see this next page. And so ultimately, this is what the page looks like. Again, you can customize this to the sky's the limit. Okay, so this is where you select the style. So here we have minimum, modern, or dark. Let's start with minimal, and we need to supply a resume document. Okay, this needs to be in the PDF format as per our validation. So I'm going to literally select Alice Whitfield's resume, okay, and click generate my resume website. This is now uploading the actual resume using textract and Bedrock to do all of the magic. Here we are. This is it, the actual web page. This is the website, folks. So this is on the CloudFront distribution website, and this is related to my particular user ID. And as you can see, this is a fully functioning web page. Okay, this is publicly available on the internet. Now, let's take a look at a little bit. So here's the summary, key achievements, experience. Okay, so Alice Whitfield happens to be an AI architect. Okay, see, she's a senior AI architect at FutureMind Technologies. Data engineer was her first role. And then if we go down to education and skills, well, you've got it all there. We've even got a button for her LinkedIn profile, which is obviously fake. There is no Alice Whitfield that I know of anyway. And obviously, that will take you to a LinkedIn page. Now, it's a very simple site, okay? And obviously, this design was constructed using that third Lambda function with all of the elements, the CSS style sheets, the HTML components, etc. You can make changes to that and add the profile image, okay? So configure the actual Lambda function to also upload the profile image and keep it in the same bucket and the same folder, and then display that there. You could modify the entire HTML layout to your heart's content, right? And obviously you can see how this works. The key thing that I want you to take away from this, folks, is the architecture that we've used to build out this exact solution. Let's actually go ahead and try something else out, okay? So let's just go back, okay? And let's change our style. Let's go for dark. And then we're going to click on choose file, and I'm going to choose Alice with field again, and then click generate my resume. This is uploading the resume, getting the processing with Textract and Bedrock to work, and then generating my website. Now, I know what you're saying. Hey, Rajesh, this doesn't look like a dark mode. Obviously not, right? This is still the minimum design. And that's because we're using CloudFront. We're using CloudFront as our distribution point, right? And remember, CloudFront is a content caching service. So what's actually happening here is Alice's page actually has been updated. In fact, let me show you where those pages are. Let's click on the S3 bucket. We can go to website. This is Alice's user ID, UUID. And if we go into it, you'll see there is her index.html page. Now, this has been replaced from what it was previously, but what CloudFront is showing you is the cached version. So we need to go into the distribution, and very quickly I can run an invalidation on what's in cache. So click on invalidation, create an invalidation, and we're just going to literally do an invalidation on /website/star, okay, and create invalidation. Okay, that's going to take a few seconds. Now, what you could do is you could actually turn off caching, okay? But basically, if it's a simple web page for your resume, you probably don't want caching if the user is going to be changing it. Or you might want to have caching, but have it cached for a short duration of time, like 1 day or whatever it might be. So this says it's completed. So if I go into the web page and do a Control-R, okay, or a hard refresh, there it is. There's my dark mode, okay? So you can see how this is actually working. This has now been updated. So Alice said she didn't like the minimum design. She wants to go for the dark mode instead. And again, all of these buttons work perfectly well. This is just basic HTML anyway, and you can customize this to your heart content. But hopefully you are beginning to now see how we went from a simple PDF document upload to an extraction that is displayed in a really professional manner. Let me actually show you the raw PDF document very quickly. Okay, this is the raw PDF document, folks. So it's obviously got some fake numbers and email addresses here, and I've not included that in the actual web page and what we wanted to extract out. So if you remember in the Lambda function where we gave the instructions, we didn't actually include some of these things, okay, because we wanted to also think about personally identifiable information. Whether you want to make that publicly available or not is something else to consider. But you can see this says summary, key achievements. You can see we've got all this. So the skills are laid out in this manner. We have redefined it to be like this. Now, what I want to do next is run through another quick demo and just show you how another resume looks. So let's bring up another resume. Okay, so this is a chap called Bob Castellano. Okay, apparently he is an executive chef, so he's in the hotel and catering industry. Notice that there is a difference in the layout, okay, between Alice and Bob. So Alice uses summary, he uses summary. That one uses, Bob uses achievements. Alice calls it key achievements. Bob calls it work experience. Alice calls it previous experience. You can see there is a difference in the way how people have built out their resumes. And this all gets very confusing. So we need Claude to help us get an understanding of the context. Education, okay, education, same. Core competencies. So he's using the phrase core competencies, but Alice is using the phrase skills, right? Let's actually create an account for Bob. Okay, so I'm going to actually come out of this altogether and just grab that distribution name again. All right, let's open that up in another tab, log back in, and we're actually going to sign out of Alice. And Bob doesn't have an account, so let's create an account for Bob. So I'm going to first create an account for Bob. Okay, so I'm going to call it Bob, okay, and put in a password. Okay, so I'm just pretending to be Bob here, whoever Bob is. and I'm going to put in an email address. Obviously, I don't have access to Bob's email address, but I'm going to put in an email address that I have access to. Okay, and then I'm going to click sign up. Okay, now obviously I've got that code, so let me grab that code and confirm my account. Okay, so I'm going to paste in my code in there and confirm my account. Okay, so I've now signed up as Bob. So Bob is going to select the modern style. He's going to choose his resume document and Bob Castellano, and then I'm going to generate my resume website. So it's uploading it. It's then doing what it needs to do next, which is processing with Textract and Bedrock. And then it's done and it's redirecting. And there you go. And you can see that when it comes to Bob's summary, it's the same summary, it's the same key achievements, it's the same experience word that we're using. So we're not using any other words. And look, even education is the same. And instead of core competencies, we're using skills. So we have to use a large language model to basically understand the context of those resume documents. Okay, so Bob obviously used core competencies, Alice used skills, and then we know that both of those things mean skills, so we can put it under skills. So you can see how we've been able to use AI as well as Python to ultimately build a deterministic application, one that we can rely upon, one that is going to give us exactly what we're looking for in terms of the outputs, so that it's consistent, reliable across the board. Okay, so there you go, folks. I hope you enjoyed it. I hope you found this tutorial really, really useful. I hope you will actually implement this in your own account. And you know what? This is a complete end-to-end solution, barring a few additional production elements like, you know, having a Route 53 configuration for your domain name and stuff like that, or perhaps improving and enhancing the HTML output so that you have an image and you have a few other buttons. I've got LinkedIn here. You could have a GitHub button, you could have a email button, so on and so forth. Like I said, the sky's the limit, and it's all up to you, folks. All up to you to actually build out complete end-to-end solutions. The best part about this build out and this tutorial, if you do it in your own account, is that you can defend it in an interview. You can talk about it in an interview. You can showcase the skills that you've developed as an architect, as a cloud engineer, and be able to hopefully clear that interview. Now, one thing before you go, notice what AI did for this project. One function call, one Lambda sends text to Claude and gets a clean JSON back. Everything else, the authorization, the pre-signed URLs, the event triggers, the whole pipeline, that was architecture. That was skill that you need to develop if you want to become a cloud engineer, a cloud architect, a solutions architect, a DevOps engineer, an AI engineer, whatever the role, you need to understand architecture and you need to understand core cloud foundational services. And so if you want to build that skill properly, my full solutions architect course is linked in the description. Complete SAA-C03 exam prep, 3 capstone projects including a serverless app with the same architecture pattern, a private Slack channel where I answer all of your questions, and a one-to-one career session with me to help you map out your career roadmap. Now, the repo for everything you've watched today is also in the description. It's free, there's no sign up. Go build it, break it, fix it. That's when it clicks. I'll see you folks in the next one. Thank you.